All right, welcome back everyone. Math 30-2, Unit D, lesson number 5, evaluating logarithms. So anytime it says evaluating, you're looking at getting an actual answer. So in the last lesson, we compared the graphs of y is equal to 2 to the power of x to its inverse, y is equal to log base 2x. Okay, and yeah, learned about the inverse. We talked about how the point 38 on the exponential went with plugging in like the x and the y, and it ended up being the inverse for the logarithm. And so the exponential 8 is equal to 2 to the power 3, and the logarithmic form 3 is equal to log base 2, 8 are equivalent. Okay, in this lesson, we're going to learn 3 methods. Okay. So we're going to look at converting to exponential form using a calculator and then changing the base of the logarithm in order to evaluate logarithms without reference to any kind of graph or table. Okay, so if you just have a logarithm right here, you're just going to, the step 1 is to make it equal to some kind of unknown value. So v for value is fine. Okay, so I guess we could read this. Kelsey was asked to evaluate this. Her work is shown below. Study her work and describe each step. Okay, so she set it equal to v. Okay, then she converted it to exponential form. Okay, so converted to exponential form, because she went 2 raised to the power of v is equal to 8. Okay, then she wrote with common base. Okay, 8 is equal to 2 to the power 3. And then we can get rid of the bases and equate the exponents. So we'll just say equate exponents. There we go. So the value is 3. So then you'd start off, or to end off, you'd write the original and just say it's equal to 3. Okay, so let's do some examples. So step 1, make this equal to v. Then we're going to write it in the exponential form. So 3 to the v is equal to 81. Then we're going to write it as a common base. Oopsies. So this is where, once again, I said like having the bases of 2 and 3 raised to the power of whatever, just memorized, it comes in a lot handy because then it saves you time. Okay, and then we would equate those, and then we would end off, so like saying, therefore, log 381 is equal to 4. Okay, do the next one, equal to v. 4 to the power of v is equal to 64. Okay, 64 is 4 to the power of 3. Okay, v is equal to 3. Therefore, log 464 is equal to 3. Next one. Okay, so these are some special cases here. So whenever we have the base and the argument the same thing is going to happen. So let's walk through this one. So 7 raised to the power of v is equal to 7. Okay, and then writing that as the same power. So like I would just say, okay, from here, like, okay, well, that's equal to 1, right? So then v is equal to 1. So therefore, log base 7 of 7 is equal to 1. And then we can say further, we can just say anytime we have a log that has the same base and the same argument, it's always going to be equal to 1. Okay, so now let's look at this one in D. Okay, so we've got base 12 and we've got argument 1. So when our argument is 1, something else is going to happen. So we set this equal to v. 12 raised to the power of v is equal to 1. Okay, so how can we write, isn't compatible, sorry, use without, sorry, technical issues. Okay, 12 to the v. So in order to write the common base, okay, the only thing that would equate a base of 12 to be equal to 1 is if I made it equal to 12 to the power of 0, right? So then v is equal to 0. Therefore, log base 12 of 1 is equal to 0. And then we can say anytime we have log base a or b or whatever, and the argument is 1, okay, the value is always going to be equal to 0. So those are two special cases that come up. Okay, and I think that they maybe even talk about them on this page. Maybe? No, they don't. Well, there you go. Oh, we talk about it again here. Okay, so example 2. The examples in class 1 on the previous page show the value of a logarithm is the power to which the base has been raised to equal the argument. Okay, so the value of logarithm is 4 because 3 raised to the power of 4 is 81. Okay, and then the second one, it's 3 because 4 raised to the power of 3, 64. For C, it's 1 because 7 raised to the power 1, and the last one, 7 raised to the power 0. Okay, so to further their understanding of the value of logarithms, Nimi and Zaniba use the information above to construct the following sentences. Okay, so Denim's attire has 5 pairs of ultra-high jeans left in stock. So Denim's attire has log 2, argument 32 pairs of ultra-high jeans left in stock. So did both did both students state the same number of the higher ultra jeans left in stock at Denim's attire? Explain your answer. Okay, so I think the way to do that would be to evaluate Zaniba's answer. So we would set this equal to a value, okay? 2 to the power of v is equal to 32. 32 is equal to 2 to the power of 5. V is equal to 5. Therefore, yes, log base 2, argument 32 is equal to 5. So did they both? Yes. All right. So then example 3, so this is that like what I was talking about, anything that's 1. So like right away, I know that this answer is going to be 0 because of my work on the previous page. Okay. And then this one right here, I know is going to be equal to 1, right? Anything right there, okay? But we'll just show the work still. Okay, so I set this equal to a value. I write it as an exponent. I write it with a common base. The only way to write with a common base would be to raise this to an exponent of 0. Okay, so therefore log base b of 1 is equal to 0. This one, like I said, I know it's going to be 1, but we're going to set that equal to v. We're going to write that as the exponential way. And then I'm going to say, okay, well, I know that there's actually a 1 there. So then v is equal to 1. Therefore, any log with the base and the argument the same is going to be equal to 1. Okay, every time. All right, so if you remember that, like that's a nice shortcut for you. All right, so now we're going to be doing some just like slightly more difficult examples. So we've got a coefficient here, our argument is a fraction here, here our argument is a radical, but no big deal, it still follows the exact same steps. Set it equal to v, okay? Now, if you remember, I need to divide this too, okay? So log 8, 512 is equal to v to the power of 2, because we just want it written in the way of like log bx, right? So then 8 raised to the power of v over 2 is equal to 512. Okay, and then 512, I'm pretty sure is 8 to the power of 3. Okay, I'm just gonna like double check, but I'm pretty sure. Click clear, 8 to the power of 3. Yep, okay. So then I can equate my exponents, cross multiply there, and then give my final answer. Therefore, log base 8, or sorry, twice of log base 8 of 512 is equal to 6. Okay, so feel free to pause this and try these on your own. Okay, but I'll just go through. So set equal to v, write it in the exponential. Okay, this right here is going to be 2 to the negative 5. So if you showed it like that, then it would be okay to then in this step just do that. Okay, and then say, okay, well therefore log base 2 1 over 32 is equal to -5. Okay, set it equal to v. Write it as an exponential. So I know that 125 is 5 cubed. And I also know that the square root of it means that I've got a rational exponent. Okay, so then therefore v is equal to 3 over 2, and log base 5, the square root of 125, is equal to 3 over 2. Okay, so same steps over and over again. Let's look at these ones. Okay, so now I've got the extra step here. I've got a base that is a fraction. Here I've got a base being raised to a power that's a log, and here I've got an operation going on here. Okay, so let's look at this one first. So same thing. I set it equal to a value. I write it so that it's exponential. Now 1/3 and 27, I can write both of those as 3 to the power of something. I would just need to say negative v, right, because the reciprocal, and then here would be 3 to the 3. So then it would be negative v is equal to 3, but then of course I would just write it as v is equal to -3. Therefore, log of 1/3, 27, is equal to -3. And you'll find that when we have those bases in like a number between, so let's just say the base is a number between 0 and 1, i.e. it's a fraction, okay, your value is going to be negative because you've got a reciprocal going on. Okay, let's look at this one. So this is still going to be equal to a value, okay? So I would say that, let's write this as a logarithm. Is that what I want to do? Oh no, silly me. Sorry, I'm going to take this first. Okay, I'm going to take this and set it equal to a value. And then I'm going to write it, right? 4 to the power of v is equal to 16. And then 16 is 4 squared. Therefore, v is equal to 2. So then I can write this right here. So I'm just going to that's going to be my v. Okay, that's equal to v. So then I'm going to write 4 to the power of 2. Oops, sorry, move the camera there. 4 to the power of 2, which is equal to 16. So therefore, 4 raised to the power of log 416 is equal to 16. And here's actually another pattern. Okay, if we have b raised to the power of log with the same base, okay, whatever this is, whatever the argument is also going to be equal to the value. Okay, all right, this example here. So each one of these, so I kind of went over here, each one of these we're going to set equal to, so let's set this one equal to v and this one equal to w. So then this one first, log 1/2 of 1/8 is equal to v. 1/2 raised to the power of v is equal to 1 over 8. So this one is going to be like this example here, where we're going to write them as 2 to the negative v and then 2 to the 3. So then v is going to be equal to -3, right? Because this is negative, I would divide. So that's this first one. Okay, so then that means that this value right here is -3. Now let's do w. So, and we won't worry about the negative because we're just going to do the operation there. We just want to worry about this log 1/2 of 8 is equal to w. So 1/2 raised to the power of w is equal to 8. So then I'm going to do the same type of thing here. Oh, I screwed up. Okay. And somebody might be saying like, oh no, this one right here, I didn't do this. This should be a negative here, which means this is a positive. Okay, this is why we show our work, so we can find it right away. Okay, so that one is a negative, or sorry, a positive 3. So I caught that because I realized I had the same answer over here for the just 8, but then I'm like, oh wait, I had 1 over 8 there. Okay, so then here, I've got W is going to be equal to negative 3. Okay, so then I've got positive 3 that I fixed, and then minus negative 3. Okay, so positive 3 minus negative 3 is equal to 6. So then therefore, this long bugger, I don't know if I can say a bugger, whatever, is equal to 6. Okay, my hand is officially cramping. Okay, so now you should be able to do questions 1 to 4. Good God, this is a long lesson. Okay, let's look at this, evaluating logarithms using a calculator. Okay, so we've got the common log and the natural log that we're going to be using. And then also there is a log base so that we can use any kind of log. Common log is base 10, okay? So these logarithms, they're common. So like if the base isn't given, then you understand it to be base 10. So like for example, we wouldn't write log base 10 1,000. We would just write log 1,000. Okay, and so then I've got this one here. Of course, there's all the different ones, but you would just, here's the log right there. So log of 1,000 is equal to 3. That's how you would evaluate it. Okay, and that makes sense because if we evaluate it to the exponential form, so this is equal to v, and then I would just write in a 10 there because I need to remember that I'm going to be raising it. 10 to the power of v is equal to 1,000. Okay, well 1,000 is 10 to the 3. Therefore, v is equal to 3. Therefore, log 1,000 is equal to 3. Okay, and then this one I just plugged into the calculator as 3, as you just saw. Okay, so anytime if there isn't a base, there is a base, the base is 10. Natural logarithms, same idea, except for the base is that Euler's constant, okay, or Euler's constant, sorry, base e right there, okay? So we wouldn't necessarily write log base e, we would write ln, okay? Ln is base e, okay? And so then there's a ln key right there. There's the Euler's constant, and there's ln, okay? So evaluate to 1 decimal place where necessary. Am I supposed to be doing this? Yeah, I think I'm supposed to be doing this here. Evaluate, clear. So if I do, let's put it to the side. Ln of 5 is equal to 1.6. So it said to the 1 decimal place. So 1.6, okay? And so if I were to show this, so this would be log base e 5 is equal to v, so pretending I don't know that yet. So then e raised to the power of v is equal to 5. Yeah, we can't make a common base for this, so they just want you to plug it in. Okay, so for this example here, you could just write the 1.6. So using this log base, okay, so this is the instructions for if you've got like the 84, 83, etc. If you've got the Inspire, okay, you hit the control and then you go to log, this one. So it'll come up like that. And then you need to put the little e in, which is if you go control and then the book, it gives you the option. So then e, enter, and then go over 5, and then there's the 1.6, okay? And then if we just do ln e, well, that should be equal to 1, right? Because this is the same as saying log e base e, which we know is equal to 1, but let's just go ahead and do it. So there's the ln button. So control ln, okay? And then we go over to the book and go over to e, enter, enter, there's our 1, okay? So there's that one. So you should be able to do from 5 to 6 on now. Okay, so changing the base of the logarithm. So if you don't have that function, okay, you still, actually it doesn't even matter if you have that function or not. Everybody needs to know how to show the change base of the logarithm, okay? So if we were to do this example here, so log base 2 of 34, if we change that into exponential form, we would run into the problem that they don't have a common base. Okay, 34 and 2, there is no common base. So we know that 2 to the power of 5 is 32, and 2 to the power of 6 is 64. So 34 would be like really close to 5. So this answer would be like roughly 5.1, I would give it. Okay, so then we can use a changing the base of the logarithm formula, and the formula is always given to you. So we're just going to see what happens here, and then we'll form our formula. So evaluate log base 416 by converting it into exponential form. Okay, well that would be, so I would say that's equal to v. 4 to the power of v is equal to 16. 16 is 4 squared. So that means that v is equal to 2. Therefore, log 416 is equal to 2. Okay, then let's look at this one. Okay, evaluate. So all of these, we see the arguments are all the same. It's the bases have changed, but the bases are the same, numerator, denominator. Okay, so if I change both of these to exponential form, okay, so let's say that this one's going to be equal to v and this one's going to be equal to w. So 2 to the power of v is equal to 16. 16 is 2 to the power of 4. Therefore, v is equal to 4. Okay, and then w, I'd write 2 to the power of w is equal to 4. 4 is 2 squared. Therefore, w is equal to 2. And then if I were to divide those two, so v divided by w, vw, I just realized, 4 divided by 2 is equal to 2, which is the same number we got there. Okay, so it says here the common logarithmic function on a calculator. So let's do, so we're just doing log, which is, so this log right here of 16, okay, and then divided by log, and I wonder if I need to put in, I think it'll do it. Yeah, okay. I wasn't sure if I had to put brackets around the whole thing. Okay, so that's equal to 2. And then it says to use the natural log function on a calculator. So that's the difference here. So then it would just be ln 16 divided by ln 4, also equal to 2. So overall we see, okay, it doesn't matter, like in order to figure this out, if we just take the argument, put it on top, we take the base, put it on the bottom, and then it doesn't matter what base we use, so it makes sense just to do the common log, because then we don't have to worry about like anything. We can just literally plug it into our calculator. Okay, so they have us doing this again throughout here. So you can pause and figure this out, but you'll see that there should be all the exact same answer. So let's just do this one. So 4 to the power of v is equal to 64. 64 is 4 to the power of 3, therefore v is equal to 3. Therefore, log base 464 is equal to 3. And so if you do all these, just the same way we did up here, you'll see they're all equal to 3. So the pattern that I'm talking about here, so use the pattern from B and C to evaluate log base 5, 25, converting to exponential form. Okay, well, this is equal to v. They're really hammering this in, hey? Is equal to 25. We know that 25 is equal to 5 squared. Therefore, v is equal to 2. And log base 5, 25 is equal to 2. Okay, changing the base of the log to base 10. So that means like this version, I think, is what they're talking about. So this is going to be in my numerator, the argument in my numerator. This is going to be the argument in my denominator. And then so log base 5, 25 is going to be equal to, so log 25, the common log. So I don't need to write the 10 is equal to that. So this, when we plug it into our calculator, should equal 2. So log of 25 divided by log of 5 is 2. Okay? So then one last question. Okay, so change of base, once again, equal to, changing the base to base 10. Okay, just kidding. It's like this one. So then we know that this is going to be my numerator's argument. This is going to be my denominator's argument. And it's base 10. So then log 3 243 is going to be equal to log of 243 divided by log of 3. Okay, which we would just plug in. Log of 243 divided by log of 3 is equal to 5. Okay. What if we did with base e? So that means log 3 243 is equal to ln 243 divided by ln of 3. Okay, so then ln 243 divided by ln of 3 still equal to 5. Okay, so then here is the change of base identity. Okay, so for any logarithm, okay, it doesn't matter what the base is. So we would, of course, just use a common log. Okay, unless you're like really feeling that ln, then you could use that. But like default to just basic log, or common log, I should say. And then the argument goes in the denominator. And, sorry, oh my gosh, the argument of the original goes into the argument of the numerator. And the base of the original goes into the argument of the denominator, okay? So then anytime the instructions say, by changing the base, you must show this, okay? If it's like a multiple choice question and you're just asked to evaluate, you can do whatever you want. But when it says by changing the base, you need to do that. So we would say for log base 4, 1024, log 1024 divided by log 4, plug it in, you're good. Okay? I know you can plug it in here, so I'm not going to show that. Here, so now there's a coefficient in front, but that's okay. So I'm going to put the coefficient in front, and I'm going to have log of 1 over 10,000. If you wanted to, you could say like log of 10 to the negative 3, but that's fine. And then log of 2. Okay, there's that, there's that. Okay, for this one here, we would, okay, well, it's this that we would do, so it would be equal to 6 raised to the power of, so log of 216 over log 6. Okay, and then you evaluate that and put whatever it is raised to the power of that. And then this one right here, okay, I've got the square root of 1024, so that's going to go into the argument, okay, and then I'm going to be over log 2. Okay, so then quick as a bunny, let's calculate these. So then we're going to have log of 1024 divided by, log of 4. So the first one is equal to 5, which I think we knew we did that one. Okay, and then this one here, oops, clear. So I'm going to have 3 multiplied by log of 1 over 1,000, okay, divided by log of 2. And then I put the end bracket here to match this bracket, okay. I feel like that's not right, but I think it's okay. Let's just do log of 1 over 1 divided by 1,000 divided by log of 2. Oh, snap. What did I do? Oh, yeah, now I need to multiply by 3. My bad. Okay, so I did do it right the first way. Okay, so negative 29, and then what does it tell us? To the nearest hundredth. Okay, so then that's going to be, so 897 would round to 0.90. Okay, now this next one, 6 raised to the power of, and then I'm going to put brackets, so log of 216 divided by log of 6. Okay, so that's going to be equal to 216, and we can just write it, 216, which we knew, right? Because we know anything that has the base right there raised to the log of the same base, it's just going to be, the value will be equal to that argument. Okay, and then this guy right here, so log of, so I've got the square root, 1 divided by 1024, and then divided by log of 2 is equal to 0.98. Ooh, negative. Don't forget the negative. Okay. And then, so like this should be good. Like I had to put brackets around it so that the square root would go all the way, right? You could also, like 10 to the 24 is equal to, or sorry, 1024. Is that like 10 to the power of like 9? Okay, so 2 to the power of 10. Okay, yeah, 2 to the power of 10 is 1024. So then just to show this the other way here, okay? So 2 to the power, so if I was doing it the old way, 2 to the power of v, so I'd write 2 to the power of v is equal to the square root of 1 over 1024, okay? And then 1 over 1024, so that's going to be 2 to the power of 10, but it's going to be a negative 10. Yeah, this one I think is jinky because I'm going to solve this one here and it's going to be equal to negative 5, I think. 2 to the v, because this is the square root, so it'd be divided by 10, or 2, sorry. Am I doing this right? Yeah, negative. So then v is equal to negative 5. Okay, I thought that one felt different. Let's look at this again. Log, because it would be this right here goes here. This right here goes there. Maybe I'm going to try just doing log of the square root, second square root of 1 divided by 1024. I wonder if that's right. What if I write it as, because that's the same as 2, so if I do 2, or sorry, log of 2 raised to the power of negative 5. What did I do? Oh, I didn't do raised to the power of, jeepers. It's now like 4:30, so my brain is like officially melted. There we go. Okay, so that's the same. So I did that right. And then divided by log of 2 is equal to negative 5. Okay, so however I did it in one big thing here. Oh, I see what I did. Right here. I have a bracket here. I need to get rid of this. So like that bracket's there. Actually, I need to add another bracket. So you go insert bracket. Now it's gonna work, boom. Okay, so when you get something jinky like that, okay, so that it should be equal to negative 5. So I just knew, I'm pretty sure that that should be like an actual whole number, okay? But just go back and make sure that you've got the brackets that you need. I didn't have this bracket right here, so it was doing in this log right here, this bracket was including all of this. So it was the square root of 1 divided by 1024 divided by log of 2. Like that was all getting logged, okay? Okay, so that was good that happened, because if that happens to you, then you'll know to check those brackets. Okay, last question. Thank the gods of math. Consider the function log base 7 x. Explain how to use a graphing calculator to produce the graph of a function. Okay, so we could use, so you could just do, like, you could just put in y is equal to log base 7x if that's one of your things that you can do. Or you could put in y is equal to, so remember, log of this argument goes up top, this base goes on the bottom. And I'm just using the common log. Okay, sketch the graph of f on the grid provided, label any intercepts. Okay, so let's go to my y equals, and then we'll do, let's just do, because everybody needs to know how to do this. So log x, how do I do that again? Oh, this one, right. Log x divided by log 7 graph, and there it is. Okay, so to match this, I see that I've got this value right here. So of course I've got an intercept, right? I know that I'm going to have an intercept of 1. Okay, and then my value is going to be 7 and 1. So it's going to be 7 here and 1. So if this is 7, and then I'm just going to mark this as 1, 1. And so I want to make this, oof, that's quite the curve there. There we go. And then remember, we always want to write down what the curve is. That's an X. There we go. Okay, and then label any intercepts. So here is 1 and 0 is my intercept. So I think I've done everything. Use the calculator graph to solve the following. Okay, so if it's equal to 5, okay, well this is a y1 is equal to y2. Okay, so I would need to plug into here. So go back to that, and I would put a 5. Okay, and then I'm gonna need to adjust, right? Because I need to move over here. So I would go to window, and then I would put my X max. I'm just gonna put 100. I don't think that's enough, but sometimes it's just a trial and error thing. Oh yeah, which, okay, that makes sense, right? Because 7 raised to the power of 5 is equal to X. So then I'm gonna need to go back to my window, and I'm gonna need, what, 7 raised to the power of 5 is, gotta love the 2 calculators here. 7 raised to the power of 5 is, 16,000. So I'm gonna put my X max at 20,000. Okay, now I should see an intersection. There we go. So now I can do the second trace. I wanna find the intersection, number 5, and then you go the left side, right side, intersection is equal to 16,807, 16,000. Okay, so X is equal to 16,807. Okay, so that's the Y1, Y2. This guy right here, this is the way you would do this. You would plug this in. So this is your Y, and then so you're looking for your X intercept. Okay, because technically your second Y, like Y1 is equal to 0 and Y2 is equal to that. Well, Y is equal to 0 is this line here, okay? So let's clear this. So I'm gonna go here, clear, clear, and then I'm gonna write in. So 3 log of base 7, math, all the way down, A. Oh yeah, this one didn't work for me before. I don't know why. This one, I'm not sure. It was being weird. But I would have 7, and then it's gonna be X. I'm pretty sure this is not gonna work, but I'm gonna see. And then we're just gonna do the other calculator. Graph, yeah, see, that's what it does for me. I don't understand what its problem is. That's okay, let's go to the Inspire. So then I go to, I have to remember now, because everything's, oh yeah, right. So I go B, graph, and then I go menu, and I want my graph entry, so 3, and it's a function. So f of x is equal to, so I've got 3, and then log, and then base 7, x, okay? And then outside, so I press over, subtract 9, okay? And then I press enter. And so I'm gonna have to adjust my windows again here. So I would go to menu, windows, and let's see if zoom fit works. It often doesn't, but let's see. Yeah, that's kind of weird. So it's all the way over there, and see, it's at 10 right here, so I'm gonna expand it to like 20. So menu, windows, window settings. So I'm gonna make my X max, I'm gonna say 20. And then my Y min, like I don't need to be -5. I'm just gonna make it -1. And then my Y max, I'm gonna make 5. Okay. And then I should see, where's my graph? Where's my graph? Isn't it still in there? Menu 3, 1. Okay, there it is. Menu 4. Let's go zoom out. And then I'm going to go down here. Enter? Oh, there we go. Oh, okay, so I guess I just need a number bigger than that. Menu, so 4, and then window settings. So then my 40 was not big enough. I'm just gonna go 200. Okay, good. Oof, still not, okay. Menu 4, window settings, I'm gonna go 500. 500. Okay, jackpot. Okay, so now I can do menu, analyze graph, if you're on these ones, 0. Okay, left side, right side, or lower bound, upper bound. Okay, and so that's at 343 is my point there. Okay, so then 343 is the answer to that one. Okay, and then solve both of them by, so that's just the graphing way, and so let's do it algebraically now. So if I were to do this, it would be 7 raised to the power of 5 is equal to x. Okay, well, 7 raised to the power of 5 is 16,807. That was way quicker. Okay, and then this one right here. So I would start by moving that 9 over, okay, is equal to 3 log 7x. And then I'm going to divide by this 3, okay, so that's going to give me 3 is equal to log 7x. And then 7 raised to the power of 3 is equal to x, which is equal to 343. Excellent. Okay, so that was good. We did some troubleshooting with the graphing, which of course is always going to happen. But that is lesson 5.